and welcome back to our YouTube channel where we make the complex world of chemistry a whole lot easier to understand. I am B. Janardhan Reddy and today we are diving into the fascinating world of IUPAC naming. In our last video, we tackled the example problems from the class 10th textbook of the SSC board Telangana, and I hope you found those helpful. But now it is time to step up our game. We are diving into the exercise problems from the very same textbook. So without further delay, let us tackle the IUPAC naming problems from class 10th textbook. In our previous videos, I covered all the IUPAC naming rules, and in this video, I will jump straight into problem solving. So IUPAC names class 10th problems and solutions. Here is the problem number 1. This is an organic compound to which we have to provide the IUPAC name. Solution: it has only one carbon chain and we have to number this chain either from left to right or from right to left. So here I am numbering it from left to right. In this compound 5 carbon atoms are there. That is, in this carbon chain 5 carbon atoms are there. So the root word is pent. Next, and this chain has only carbon-carbon single bonds. Depending upon the nature of saturation, we get the primary suffix here. Carbon-carbon single bonds means ane. Primary suffix is ane. The name of this compound, IUPAC name of this compound is pent plus ane, pentane. Next, problem number 2. Solution: this is an organic compound to which we have to provide the IUPAC name. First, we have to select the parent chain, that is the longest chain of carbon atoms. So this one is the parent chain, and one side chain, otherwise substituent, has been attached to this carbon atom. The numbering of the parent chain is done in such a way that the carbon atom carrying the substituent should get the lowest possible number. For that reason, I am numbering this parent chain from left to right. 4. Okay. So in this parent chain, 4 carbon atoms are there. So the root word is but. Next, primary suffix. Here in this parent chain only carbon-carbon single bonds are there. So ane. Primary suffix is ane. Secondary prefix, otherwise substituent, is methyl. To the second carbon atom, methyl group is attached. This is called as a substituent. So the name of this organic compound is 2-methyl-butane. Next, problem number 3. Solution: first we have to select the parent chain. You can select this as the parent chain or this one as the parent chain. In both cases, the number of carbon atoms in that chain is same. So here I am selecting this as the parent chain and the remaining these two are substituents. Okay. So I am numbering it from left to right. In this parent chain, 3 carbon atoms are there. So the root word is prop. Primary suffix is ane because only carbon-carbon single bonds are there. Ane. Next, secondary prefix, otherwise substituents, methyl. So to the second carbon atom, two methyl groups have been attached. Okay, so the IUPAC name of this organic compound is 2,2 dimethyl propane. Next problem, problem number 4, solution. So obviously we can observe this as the parent chain, and one methyl group has been attached to the carbon atom here. If only one substituent is there, at that time the numbering of the carbon atoms in the parent chain is done in such a way that the carbon atom carrying the substituent should get the lowest possible number. For that reason, I am numbering this chain from right to left. 4. Okay. And there are 4 carbon atoms in this parent chain. So the root word is but. Primary suffix is ane because only carbon single bonds are there. So it is ane. Next, secondary prefix is methyl. IUPAC name is 2-methyl butane. Next, problem number 5, solution. So here we have to select the parent chain. The parent chain is not necessarily a straight chain. It could be a zigzag continuous chain. So you can see here, this is the parent chain for this compound, this one. Okay. In this parent chain, there are no substituents. For that reason, you can number the parent chain either from top to bottom or from bottom to top. So the root word, 5 carbon atoms are there in this parent chain. So it is pent. Primary suffix is ane because only carbon single bonds are there, and no secondary prefixes, otherwise substituents attached to any carbon atom. IUPAC name of this organic compound is simply pent plus ane, pentane. Problem number 6, solution. And this one is the parent chain, and one chlorine halogen atom is attached to this carbon atom. So only one substituent is there. At that time, numbering of the parent chain is done in such a way that the carbon atom carrying the substituent get the lowest possible number. For that reason, this parent chain is numbered from right to left. Okay, so this one is the parent chain. Let us number it from right to left. Okay, 5 carbon atoms are there. So the root word is pent. Only carbon single bonds are there. So the primary suffix is ane, and there is one substituent called chloro. Okay, so the name of IUPAC name of this organic compound is 1-chloropentane. Problem number 7, solution. It is similar to the previous one only. The only thing is that the position of the chlorine is changed. So this is the parent chain, and I am numbering it from right to left so that the carbon atom bearing the substituent should get the lowest possible number. Root word pent, primary suffix ane, secondary prefix chloro. So 2-chloropentane. Next, problem number 8, solution. In this case, two substituents have been attached to the parent chain. So this one is the parent chain. And at that time, we have to find out the locants. What are locants? I already explained in our previous videos. The number that locates the position of the substituent is known as locant. So here I will prepare the two sets of locants. First, I will number the parent chain from left to right and from right to left also. Here I will use one rule called lowest set of locants rule. See here, set 1 locants left to right 3, 4. That is, third and fourth carbon atoms are bearing substituents. Set 2 from right to left 2, 3. These are the locants. 2, 3 are the locants from right to left. So we have to compare these two sets term by term. So here I am comparing these two terms. Here 2 is less than 3. So at the first point of difference 2 is less than 3. Then you no need to compare the remaining terms. That means numbering from right to left is the correct way of numbering. Okay. Root word is pent, primary suffix ane, chloro. This one is a substituent. So 2, 3 dichloropentane. 2, 3 dichloropentane. Next, problem number 9. Solution. So I am numbering the parent chain from right to left for the same reason mentioned above. 1, 2, 3, 4, 5. Root word pent, primary suffix ane, secondary prefixes, otherwise substituents bromo and chloro. Okay, so the IUPAC name is when more than one substituent is attached to the parent chain. The substituents are to be written according to alphabetical order. So bromo comes first. For that reason I am writing 2, 3. 2, 3 dibromo, 2, 3 dichloropentane. 2, 3 dibromo, 2, 3 dichloropentane. Next, problem number 10. Solution. First we have to select the parent chain. This one is the parent chain. Okay, here CH2 is written in the form of structural formula. Okay, so for that reason these two hydrogen atoms are not the substituents. It is CH2 only. And I will number this parent chain in both ways. Later I will decide which way of numbering is correct by using the lowest set of locants rule. 1, 2, 3, 4, 5. From right to left also 1, 2, 3, 4, 5. Let us use the lowest set of locants rule to decide which way of numbering is correct. Set 1 locants from left to right 2, 3, 3. That is here second carbon atom and here third carbon atom are bearing the substituents. Next, set 2 locants are, see here, 3, 3 and 4. Let us compare these two sets by term. So here at the first point of difference, here I am comparing the first terms. Here 2 is less than 3. Then you no need to compare the remaining terms. So at the first point of difference 2 is less than 3. That means numbering from left to right is the correct way of numbering. Okay. Root word. See here. Pent. And primary suffix is "-en", secondary prefix. There are two secondary prefixes, chloro and methyl. IUPAC name. We have to write the substituent as per the alphabetical order. So chlorine comes first, methyl comes later. So 2, 3 dichloro 3-methyl pentane. Next, problem number 11. Solution. In this compound, multiple bond, that is double bond is present and substituents are present. This one is CH2 group only. Okay. So here this one is the parent chain. While selecting the parent chain and numbering it, we have to use this order. Functional group is given more priority than double bond or triple bond, and double bond or triple bond is given more priority than substituents. Here chlorine and methyl, these are the substituents, but here double bond is there. So this one is the parent chain. I have selected. This is the only longest chain of carbon atoms in this compound. So this one is the parent chain. And while numbering this chain, we have to give the priority to the double bond than substituents. For that reason, I am numbering this parent chain from left to right. Okay. So the root word is pent. Primary suffix, you can see here, double bond is there. It means "-en". And there aren't any secondary suffixes, otherwise functional groups. And only substituents or secondary prefixes are there here, chloro and methyl. So the IUPAC name of this organic compound is, you see here, we have to write the substituents as per the alphabetical order. So 2, 3 dichloro 3-methyl pent 1-ene. The position of the double bond also should be mentioned. Okay. So 2, 3 dichloro 3-methyl pent 1-ene. Here the position of the double bond is 1. Okay. Next, problem number 12. Solution. First we have to select this as the parent chain, this one as the parent chain, and chlorine is substituent, and two double bonds are there in this parent chain. Okay. So while numbering the parent chain, here we have to use this priority order. Double bond or triple bond are given more priority than substituents. So first here I will use the lowest set of locants rule. Here locants are nothing but the numbers that locate the position of the double bonds are known as locants. For that reason, I am numbering the chain from left to right and from right to left also. From right to left also I am numbering it. So which way of numbering is correct? In order to know that, I will use the lowest set of locants rule. set 1 locants, that is 1 comma 2. It means that the first and the second carbon atoms are bearing the double bonds. From right to left, fourth comma fifth carbon atoms are bearing the double bonds. Let us compare these two sets of locants term by term. So at the first point of difference, 1 is less than 4. That means set 1 is the correct way of numbering. So from left to right is the correct way of numbering. Root word is hex because 6 carbon atoms are there. Primary suffix here, double bond is there. 2 double bonds are there. So it is in. Secondary prefix, otherwise substituent is chloro. So the name of this compound is, IUPAC name of this compound is 4,4 dichloro hexa. See here, when there are 2 double bonds in the molecule, the IUPAC name is alk plus adiene, alkadiene. So here we have to attach A to hexa. So 4,4 dichlorohexa, 1,2 diene. We have to mention the position of the double bonds, to which carbon atoms double bonds are attached here. 1,2 diene. Next, problem number 13. Solution. In this parent chain, you see this one is the parent chain. It contains 1 triple bond and 1 double bond, 2 substituents, bromine and chlorine. Okay. So while numbering the parent chain, we have to use this priority order. So I will number this parent chain from left to right and from right to left. Later I will decide which way of numbering is correct. Okay, from right to left. And here we have to identify the locants. That is the numbers that locate the position of the multiple bonds. Okay. Lowest set of locants rule. Set 1 locants are left to right. You see here, first carbon atom is bearing the triple bond and third carbon atom is bearing the double bond. So left to right locants are 1, 3. Next, set 2 locants 2, 4. Now we have to compare these two sets of locants term by term. So at the first point of difference, 1 is less than 2. So left to right numbering is the correct way of numbering, and numbering from right to left is the wrong way of numbering. So here root word is pent. Primary suffix, you can see here 2 primary suffixes are there here. Double bond is there, so it is in. Triple bond is there, it is ein. Okay, and 2 substituents, otherwise secondary prefixes are there, bromo and chloro. IUPAC name, this is very important one. In the parent chain containing both double and triple bonds, the terminal E in the name is dropped when it is followed by the suffix beginning with A, I, O, U or Y. See here, 5 bromo, 4 chloro, pent, third carbon atom is bearing double bond, so in 1 ein. Here E from the word ENE is dropped. Why? Because here it is followed by the suffix beginning with Y. For that reason here E is dropped. Next problem number 14. Solution. First we have to select this as the parent chain and it contains one triple bond and one double bond. And these two are the substituents. OCH3 means methoxy and here chloro. While numbering the parent chain, we have to give the priority to the multiple bonds than substituents. For that reason, I am numbering the parent chain from left to right. Okay. And root word is pent, primary suffix. Double bond is there, so it is in. Triple bond is there, it is ein. Secondary prefixes you can see chloro and methoxy. IUPAC name of this organic compound is, we have to write the substituents according to the alphabetical order. So 4-chloro, 5-methoxy, okay, 3-ene, 1-ine. 4-chloro, 5-methoxy, pent, 3-ene, 1-ine. Next problem number 15. Solution. In this compound, carbon atoms are forming a ring. So it is a cyclic compound. In this cyclic compound, 5 carbon atoms are there. So the root word is pent. Primary suffix only carbon, carbon single bonds are there. So it is ane. And here primary prefix will come into picture. There is only one primary prefix called cyclo and it is used only for cyclic compounds, that is when carbon atoms are formed ring-like structures. Okay, so cyclo. There aren't any substituents. The name of this cyclic organic compound is cyclopentane. Next problem number 16. Solution. It is similar to the previous problem only. The only thing is that double bond is present in the ring. Root word pent, 5 carbon atoms are there in the ring. Primary suffix is ene because carbon-carbon double bond is present in the ring. Primary prefix is cyclo. IUPAC name cyclopentene. Next problem number 17. Solution. This is a cyclic compound containing double bond and substituent here. Okay. So cycloalkenes and cycloalkynes. The numbering of double or triple bond is done as 192. The direction is so chosen as to give lowest numbers to the substituents. So here double bond is there and the carbon atoms bearing the double or triple bonds are given 1 and 2 numbers. So the direction of numbering can be done either in clockwise or anti-clockwise. And we have to choose the direction of numbering the ring in such a way that the carbon atoms bearing the substituents should get the lowest possible numbers. So in this case, numbering can be done starting from here 1, 2, 3, 4, 5. At that time, third carbon atom is bearing the substituent bromine. If numbering is done starting from here anti-clockwise 1, 2, 3, 4, 5, then the carbon atom bearing the substituent will get fifth number. So for that reason, I am numbering the chain starting from here in clockwise direction. 1, 2, 3, 4, 5. The root word is pent. Primary suffix double bond is there in the ring, so it is in. Primary prefix, here carbon atoms are formed ring. Okay, so primary prefix is cyclo. Secondary prefix, only one substituent is attached to the third carbon atom, that is bromo. So 3 bromo cyclopentene. Next, problem number 18. Solution. In this cyclic compound, a double bond is there and two substituents, bromine and chlorine atoms, have been attached to these two carbon atoms in the ring. So numbering is done in such a way that substituents, the carbon atoms bearing the substituents, should get the lowest possible numbers. And wherever double bond or triple bond is there, the carbon atoms bearing the double or triple bonds should be given 1 and 2 numbers directly. So the numbering can be done starting from here in clockwise direction or starting from here in anti-clockwise direction. Which way of numbering is correct? In order to know that, we have to use the lowest set of locants rule. Okay, or we can give the number starting from here in clockwise direction. So let us use the lowest set of locants rule to decide which way of numbering is correct. Set 1 clockwise locants are, see here, 3, 4. Third and fourth carbon atoms are bearing the substituents. Set 2 locants starting from here anti-clockwise direction. Numbering has been done, so fourth and fifth carbon atoms are bearing the substituents. Now we have to compare these two sets of locants term by term. So here I am comparing the first terms, 3 is less than 4. That means at the first point of difference, 3 is less than 4. Then you no need to compare the remaining terms. So numbering in clockwise direction starting from here is the correct way of numbering, and this one is the wrong way of numbering. So root word is pent, primary suffix is in, primary prefix cyclo, secondary prefixes bromo, chloro. So 3 bromo, 4 chloro, cyclopentene, IUPAC name. 3 bromo, 4 chloro, cyclopentene. Next, problem number 19. Solution. In this cyclic compound, one double bond and one triple bond is there, and two substituents, bromine and chlorine atoms, have been attached to these two carbon atoms. So when a double bond and triple bond both are competing for the same position in the ring, at that time double bond is given more priority than the triple bond. So numbering 1 and 2 should be given to these two carbon atoms. So we can number the ring starting from here like this or starting from here like this. So if you give the numbering starting from this carbon atom in clockwise direction, you will get 1, 2, 3, 4, 5. Fourth and fifth carbon atoms are bearing the triple bond at that time. Suppose if the numbering is done starting from here in anti-clockwise direction, 1, 2, 3, 4, that is third and fourth carbon atoms are bearing the triple bond. So I am numbering starting from here in anti-clockwise direction. Root word pent primary suffix, one double bond is there and one triple bond is there, so it is in, ein. Next, primary prefix cyclo, secondary prefixes bromo, comma, chloro. So 2 bromo, 1 chloro, cyclo, pent, 1 in, 3 ein. 2 bromo, 1 chloro, cyclopent, 1 in, third carbon atom, 3 ein. Here E is dropped. Why? Because it is followed by the suffix beginning with Y. Next, problem number 20. Solution. This is the longest chain of carbon atom, that is the parent chain. In this case, functional group is attached. OH is one of the functional groups. Okay. So whenever functional group is there, we have to give the numbering in such a way that the carbon atoms attached to the functional groups should be given the lowest possible number. For that reason, I am numbering this chain from right to left. Root word pent, primary suffix only carbon, carbon, single bonds are there, so it is in. And here there is a secondary suffix OH. OH means ol, alcohol. Alcohol functional group, it is ol. The name of the secondary suffix for alcohol functional group is ol. IUPAC name is pentane 1-ol. We have to mention the position of the carbon atom to which the functional group is attached. So pentane 1-ol. Here E from ANE is dropped because it is followed by the suffix beginning with O. Okay. Next, problem number 21. Solution. In this organic compound, double bond is there, substituent is there, and functional group is there. And when functional groups, multiple bonds and substituents are present in a molecule, functional groups are given the highest priority while numbering the parent chain. So this one is the parent chain, and here OH is the functional group, alcohol functional group. The carbon atom attached to the functional group should be given the lowest possible number in this case. For that reason, I am numbering it from right to left. Root word pent, primary suffix in, secondary suffix you can see here OH, alcohol functional group is there. The secondary suffix for alcohol functional group is ol. Okay, and chloro, substituent is chloro. Name of this compound is 2-chloro pent 4-in-1-ol. 2-chloro pent 4-in-1-ol. Problem number 22. Solution. This is an organic compound containing functional group COOH, carboxylic acids functional group. And COOH is one of the chain terminating functional group. See here, these are the chain terminating functional group. When a chain terminating functional group is present in the organic compound, we have to take the carbon atom in that functional group while selecting the parent chain. So this carbon atom should also be included in the selection of the parent chain. So numbering is to be done from this way, and root word is 6 carbon atoms are there, so it is hex. Primary suffix is ane. Secondary suffix, the secondary suffix for carboxylic acid's COOH functional group is oic acid. So the name of this organic compound is hexanoic acid. Here E from ANE is dropped because it is followed by the secondary suffix starting with O. Problem number 23. This one is the last problem in this video. Solution. In this organic compound, OH functional group is there and chlorine substituent is there. So numbering of this carbon chain is done in such a way that the carbon atom attached to the functional group should get the lowest possible number. For that reason, I am numbering it starting from right to left. Okay. Next, root word is pent, primary suffix ane, secondary suffix OH functional group is there. The secondary suffix for alcohol OH functional group is ol, and secondary prefix is chloro. So 2-chloro pentane 2-ol. 2-chloro pentane 2-ol. Here also E from ANE is dropped. Why? Because it is followed by the secondary suffix beginning with O. Okay. Thank you.